Okay, it's our first day in Honors Higher Algebra, and we're doing something called arithmetic and geometric sequences. We're going to find terms of different arithmetic and geometric sequences and basically figure out what term number it is. So let's just talk about a simple sequence you guys can all relate to. 2, 4, 6, 8, dot, dot, dot. You've heard of it, it's the even numbers, right? But there's a really fancy way to describe what's happening here. And so pay attention, this is important. When I say this is u sub n, that's like any random term in the sequence. I could have picked the 4 or the 8 or some number in the future. I could have picked any of them and called it u sub n. N means I don't know which one it is. If I had picked out this very first one and said that it was u sub something, it probably would have been u sub 1. But it could have also been u sub 0, because the maker of the sequence gets to decide if it's the 0 term or the first term. Do you get what I'm saying? Now, if I thought you guys were really slow, I wouldn't have told you that. I would just say u sub 1 is always the first term. But I think you can handle it. Sometimes you start with, let's say the year is 2025. Their first term might be u sub 2025 because that's what it was in the year 2025. See what I mean? So you don't always have to start with u sub 1. Usually, you do start with u sub 1. All right, and if I did start with u sub 1, this would be u sub 2, and then I guess this one turned into u sub 3. But if I don't know which term it is, I call it u sub n. All right, are you with me so far? So if I'm trying to say that, you just always add 2 to get to the next number? Then here's how you would say it. My first term is, I'm going to stick with u sub 1 for your very first one like this. U sub 1, you have to tell people where you start, right? U sub 1 is 2. Then I could say u sub n, which is any term, u sub n, is equal to, and I want you to put a little parenthesis around this n, because if you, later when we put it in the calculator, you have to have a parenthesis around it. You might want to write this down. This is important. This is what your next test is like, is can you write these descriptions of sequences? Do you agree that the concept is you take the number and you add 2 to it to get to the next one? U sub n is given by, what's the term in front of u sub n? It's u sub n minus 1. What's the term after it? It's u sub n plus 1. And I'm saying sub as in subscript, because you're supposed to write these as little subscript numbers. All right. So I'm going to go off to the side here. Don't write this down. But if I had a sequence that was at like 23 and the next number, let's say the O is add 5, and it was at 28, and then there's numbers before this and there's numbers after it. I don't know which term this is. I'm supposed to call it u sub n. What's the term right in front of it called then? Just told you a second ago. Yeah, u sub n minus 1. Do you get it's whatever term that was, you would subtract 1 from it to get that term? So if it turned out this was u sub 23, then the one in front of it would be u sub 22. But since I don't know what it is, I call it u sub n, because I don't know what term it is. Then the term in front of it would be u sub n minus 1. You get that so far? All right. So back to this. This was me just naming these. And then erase those now. Now we're back to the nice even numbers. Very simple. Starts with 2. Goes up by 2. So let's see if you understand when I say u sub n is equal to u sub n minus 1. That's the term in front of it, right? Any random term is given by the term in front of it plus 2. There. That's how you define recursively a sequence. Once you've done a couple, you're going to be like, oh my gosh, that was so easy. I know right now it looks like 3. There's very few times in class where you say always. But you can always write this for all of your problems that we do. It'll always say u sub n, which is any random term, equals u sub n minus 1, which means the term right in front of it. And then you usually add or subtract something. So, let's see if you understand what I mean by this then. 3, and then I'm going to add 3 and I get 6, and then I'm going to add 3 and I get 9, and then it keeps going like that. If you're incredible at math, you could already tell me the answer to what's the formula for this. What's the way to describe this recursively? But I know it's a little bit too much to ask, so I'm just going to tell you. u1 is equal to 3. So you tell people how to start. First term is 3. What did I say would always come next? U sub n equals u sub n minus 1. You technically don't have to have the parentheses. But the reason I put them in is because on the calculator, when we do these like 3 days from now with a calculator, oh, side note, bring a calculator. A regular calculator won't work, only this fancy graphing kind. How many of you have one of those like $100 graphing calculators? Like, awesome, almost everybody. If you don't, this would be the time to ask mom and dad to buy you one. Because honestly, we're going to use it for this whole unit and the test. On the test, I will have like 3 that I can lend out to people that don't have one. Do you get there's probably more than 3 people that don't have one? You could get stuck without one. So I strongly recommend. Now, if you cannot afford a calculator, I know that does happen in certain situations. Just catch me after class when nobody else is around and just say, hey, Mr. Server, I'm one of those kids that actually can't afford the calculator. I will get you one. I bought a whole bunch on eBay when I found them used. And so I got a used calculator for you that I'll just give you if you can't afford one. You just have to have the guts to come up and tell me that, okay? But if it's just like, I haven't asked my mom yet, well, then go ask your mom. But if you can't afford it, talk to me. I can get you one. All right? All right. So I have a calculator because when you type these into the calculator, they have to have the parentheses. That's why I'm doing that. And then this one, it's not adding 2 each time. It's just adding 3. So you put a plus 3. Raise your hand if you already had that. Awesome. You see, that's how to write a recursively defined sequence. All right. So what if I go backwards? What if I give you the sequence and you have to tell me what the terms are? Like, if I gave you that, you'd be able to create that? All right, let's do that. Everybody write this one down. U sub 1 equals 100. U sub n equals u sub n minus 1, which really means any random term is given by the term in front of it plus 5. Would you please write out the first 3 terms? And yes, 100 is the first term. You should include that when you make a list of the first 3 terms. A lot of people just like think, oh, you don't mean the 100. You already gave me that. Yes, the 100 is one of the first 3 terms. Write out the first 3 terms, and in a second, I'm going to have you check it with the kid next to you. But this is an important moment. You're going to only learn one name today besides your own, and that's going to be the person across from you, and I'll show you what I mean, because there's lots of across froms. These 2 rows, rows 1 and 2, there's a person directly across from you. Your job right now is to get an answer to that. What are the first 3 terms? Write it down. And then you're going to talk to that person, and you're going to find out 2 things. Do they have the same answer as you, and what's their name? And you should write it down. Okay? I noticed the kid with their headphone in. I know you digged it out. All right, these 2 rows, straight across, and then you guys, it's going to be a little more unique. It's you 2, and you 2. All right, talk to that kid next to you. Get their name. Write their name down. You're going to forget it. All right. Yeah, don't be shy about asking them how to spell it. People have unusual spellings for their names sometimes. Okay. Did you know that it was 100 and then 105 and then 110? Raise your hand if you understood that. Okay, awesome. So, now how do they get more complicated? Well, first of all, the kind we were doing there is the kind where you would add or subtract. Those are called, it spells like the word arithmetic, but you say it arithmetic. These were arithmetic sequences. All of the kind where you add or subtract are called arithmetic. Do you get that if I just changed one little thing and changed this to a times by 5, it's going to be different. It won't be arithmetic anymore. From context, can anybody tell me what they think this is then? Geometric, very good. So there's two kinds. You either add or subtract something, and that's arithmetic, or you multiply by something. And you might think we also may divide by something. Nope. Yeah, only multiply. But if you want to divide, just multiply by a fraction, and it has the same effect as dividing, right? All right, so if I multiply by 5, this is called a geometric now. All right, cool. Well, the good news is that today's lesson, we've pretty much covered almost everything that you'd have to know for today, except for a few terminology things, like there's something called a common ratio, and you'll learn a couple more terms for it. But I just want to make sure you really got this. So if I gave you this sequence, it starts at 220, and then it subtracts 5 each time, and it goes to 215, and then 210. Can you write the equation for that? It's called a recursive equation. If you're like, I don't remember how to start, you won. Rohan, what'd you get?
U of 1 equals 1.
Good, and say sub 1 next time. U sub 1. And the next thing?
U sub n
Yup.
equals U sub n minus 1.
Perfect.
Minus 5.
Minus 5. Raise your hand if you had that one right. Cool. All right. Now, one more thing. I didn't want to tell you this up front because it was already kind of confusing enough, but we have to add one little thing called the domain. Okay. Domain means what numbers can you use this for? Like, what can you safely put in this? And this will predict any future term. Like, if I wanted to keep going and get another term and another term, I could keep doing that. But you know what it can't do? It can't tell what was in front of the other one. I know that seems weird. You should just be able to assume, but you can't assume. You have to know that we start there and maybe there's nothing in front of it. We don't want it to go anywhere, in that direction. Okay, so that's the idea of a domain, is saying this only works to predict the second or the third or the fourth or the fifth term. So if it's only going to work to predict the second term, then I would say that n, which is the little sub number, has to be 2 or bigger. Well, not 1. That's a good question. I know. This guy's the best. He used to be a math teacher. Then he went to the dark side. But anyway, Mr. Best knows that we're going to talk about, like, why can't you say n is greater than or equal to 1? Like, why wouldn't that be okay? So this formula only works to tell you the second term. It won't tell you the first term. Do you get this formula here? Can't tell you. Doing that can't tell you what the first term was. All right, so if you want to keep it simple, see this number right here? See that one right there? That's our first term, and you can't predict what number would be first. You have to be told what number is first. So this will always be one bigger than that number. Okay, so if we started with u sub, remember how I said we could start with u sub 2025 because it was like odd value for this year? Then could we predict what happened in 2025? No, we have to be told the first number. But we could predict the one after that. So if I add a 2025 here, then this would be, it'll only work to predict 2026 or later. Good to see you, Mr. Best. All right, so don't even write this, just listen. I'm going to start with u sub 11 is equal to 123. That means my first term, I get to pick what to start with. I'm starting with 11. You know how this will always be there? And I'm putting parentheses because you have to have them on the calculator. And then I add 6. Do you get this starts at with 123? Add 6. It's arithmetic. And can anybody tell me the domain? Be bold. Give an answer. You got this. If you're wrong, it's okay. Yes.
N equals, n is greater than or equal to 12.
Yes! Just one bigger than that. It'll only predict the 12th term or later because the 11th term was first. So you just make it one bigger than whatever that number was. All right. That'll be something that's on the test. The calculator doesn't have to have this. This is kind of optional when putting it in the calculator because the calculator knows that it'll only work to predict the term after that. But you'll have to write this on the test. So try to remember to squeeze in that domain. It's like the most forgotten thing. Because all of this will tell you the answer. This is just like a math thing that's saying, oh, by the way, this only works for the second, and the third, and the fourth, and the fifth term. Yes?
I have confused on why you add 6.
All right. I got to just pick this one. I got to say it would, I can pick it to do anything. Now, I chose that it was going to add 6. You can change that if you want to. What do you want us to do each time? You want to make it subtract 10? We could do that. Okay, so I just picked one. I just started with anything. I started with a random number, and I added a random thing at the end. But the key was, would you figure out that the domain on this depends on that number? So I was just trying to get you to think about how that domain would get written. All right, so one more from the top. We're going to start with 30. We're going to make it times by 2. 30 times 2 is 60, times 2 is 120. I think you get the point, dot, dot, dot. Usually after the first 3 terms, you get the point. I want to make a point, though. Do you get if you only had 2 of them? You can't tell if I multiplied by 2 or if I added 30. That's why you have to have 3 numbers. That's why we always ask you for 3 terms of it, because we got to see, does the kid know we're not just adding 30 here? Okay, so we're going to usually ask you for 3 terms. If I give you that, can you give me the equation including the domain? And you might say, well, I'm not sure if I should start with u sub 1 or u sub 0. Or if you get to pick, you get to pick. You want to be a u sub 1? Start with u sub 1. You want to start with u sub 0? Start with u sub 0. It's weird, but if you want to start with u sub 20, you can. Give it a shot. Nordstrom, what'd you start with?
Oh, I did 1
So u sub 1, keep going.
equals 30.
Keep going.
U or sub n.
U sub n.
U sub n equals u sub n minus 1
Yep.
times 2.
It's like subscript. U sub n minus 1 and then times 2. Perfect, if you can do the domain right.
N is greater or equal to 2.
Yes. It's just one bigger than that. If you don't get what the domain is, it's okay. I did explain it, and I'll explain it one last time. It's saying that this formula will only work to predict u sub 2 or bigger than that. It can't tell you u sub 1. All right. And if I gave you this formula, would you be able to go, oh yeah, so you want me to start with 30? And I times by 2 makes 60. And I times by 2 again is 120, and you can keep going forever, right? All right, cool. Now, there's two kinds, geometric and arithmetic. What's the multiply kind? Geometric. What if you want to divide? Then you multiply by a fraction. Okay, still geometric. Yep. So like 60 turns into 30, turns into 15, dot, dot, dot. Do you get that? That's a sequence too? Please try writing the equation for that. All right, and then there's only one more thing I have to add on, which is basically some terminology. And then you'll actually be done with learning today's stuff and tomorrow's stuff. So when you have a sub tomorrow, well, I get the surgeon to give me an opinion on whether we should take some tendons from in my thigh to make tendons for my knee. Oh my gosh, that sounds awful. Or if we should use cadaver tendons, which is like tendons from dead people. Or if we should use, I don't know if they got some kind of fancy string they can put in there instead of a tendon. I don't think so. I think you actually have to use human tissue. So anyway, while I'm doing that tomorrow, you guys will just happily be doing math class. Be happy you're new in this case. I'd far rather do math class. Okay. Well, I bet you started with u sub 1. Most kids do, and it's totally fine. Could have started with u sub 0 if you wanted. And I say 60. And then I go u sub n, parentheses optional, u sub n minus 1. Only the calculator has to have them. And then, am I adding something? No. Am I multiplying by something? Kind of. I'm multiplying by a half, or 0.5 would have been fine. Raise your hand if you had that one right. Cool. For extra bonus points, did you say n is greater than or equal to 2? Because a lot of people will forget that on the test. That's called the domain. You have to have it. Okay. Now, remember how I said you could start with 0 if you wanted to? It's a very common thing to start with if it's the real world. And I'm starting the lesson for tomorrow now. Okay? In the real world, we start at time 0. Let me give you an example. At time 0, as in like right this second, we have, I'm rounding here, about 6 million people in Minnesota. 6M, or I'll just write it out. 6,000,000. All right. There's about 56 million people in California. So just to get perspective, Minnesota's small, but it's not anywhere near the smallest. One of the smallest states is pretty close to us. You guys know what touches Minnesota as an extremely small state? What?
Like size-wise?
Oh, that's a good point. Number of population size. Yes, North Dakota. North Dakota it's fairly big size-wise, but it's so few people. All right, let's take our Minnesota population, and let's say that we are growing by 4% per year. Do you get I just gave you a starting number? And that's in the year 2025. Well, can you write the equation? U sub 2025. I'd rather use U sub 1. Trust me. Get a problem where they give you the year? You should probably start with the year. U sub 2025 is 6 million. Now, I'm going to take notes on this one because there's a few words that are important here. Remember how I said always? U sub n equals U sub n minus 1. That's one thing about these that's consistent. That's what you always do next. And now, I said it was going to grow by 4%, and a really common mistake answer is to say times 0.04. No. Do you get that would make it shrink? So then what should you multiply by to get it to grow by 4%? 1.04. Very good. Now, I'm going to break that part up, and I know for some of you, you're going to be like, I don't want to have to do that. Trust me, you want to say 1 plus 0.04 because of where we go with this formula eventually. Like this is day 1 of the unit. Well, technically, I'm now teaching you 2 of the unit or day 3 of the unit. So this is all getting kind of put together into one big thing. But by the time we get to like day 9 of the unit, you'll have to have it in this format with the 1 plus, because we're going to take and divide this by how many days it took to do it. And they'll be like divided by 12 if it's like monthly or etc. So my point is, trust me, use 1 plus 0.04 instead of 1.04. Okay, now, do you get that that'll make it grow by 4%? Do you get then, if you could put this in a calculator, which we will eventually, I'm giving you time, not tomorrow, but the next day, bring your calculator, you'll really want one. I could easily then figure out what the population will be in the year like 2035. It'd be super easy to do. And the calculator would do it. And you just have to type in U sub 2035 and your calculator will say, oh, it's this. But you have to know how to put it in the calculator. So I'll show you that. Not tomorrow, but the next day. So in tomorrow's lesson, they look like this. Are you with it so far? Okay. Now, what if they had said, is this arithmetic or geometric? What would your answer have been? Geometric, because you're multiplying. Okay. This one I don't think anybody knows the answer to, but maybe. What do you think the common ratio is? All right, then you're going to learn something. The common ratio is all of this together is called the CR, common ratio. All of that together is the common ratio. So 1.04 is the common ratio. I want to understand why it uses the word ratio. I'm going to give you a really simple one. 2 times 2 is 4, times 2 is 8, times 2 is 16, dot, dot, dot. Do you get, if I divide this one by this one, it's a ratio of 4 to 2. Do you get when I divide that, I get 2? And if I divide this divided by that, I get 2, and this divided by that, I get 2. Then 2 is the common ratio, because it's a ratio of like 16 over 8. It's like the second number divided by the first number. That's why it's called the common ratio. Well, this one is really simple. It's timesing by 2. This one's timesing by that. So that's the common ratio. So that whole thing, it's called the common ratio. And when I say 4% is the rate, some people are going to be like, wait a minute, I thought you said that it was called a ratio. The whole thing is called the ratio. This part right here, that part, I should use a different color. I'm going to use blue. That part is called the rate. Now, it can be a rate of growth, or it could be a rate of decay. Do you get some things go down over time? Unfortunately, our moose population in Minnesota has gone down over time. If we were doing the moose population, we would have used a minus right here, and then it would have been 1 minus 0.04, which would have been 4% decay. Like it goes down 4% each time. All right. Now I've taught you everything. I know it was all very fast. I'm going to go through a few examples at the end, but then I've taught you everything that you need to know to be able to do well on today's homework and tomorrow's homework. And that was a lot. I wish I didn't have to teach you all of that, but the reality is I know that'll go a lot better than having the sub try to teach it to you, and it's always different when the sub teaches it. So, all right, so here's one. Imagine that we're talking about Louisiana. And let's say Louisiana, use 0. Could I have done the year I was doing, like U sub 2020 or something? I could. But I'm starting with U0 because I get to pick that. And the population in Louisiana is, let's say, 12 million. If I said U sub n equals U sub n minus 1, you just know that's kind of the main thing that you write in there every single time. And it's saying any random term is given by the term in front of it times, and this is the key. You're wondering, I wonder if it's growing or shrinking. Do you get that the population is decaying or shrinking by 2%? So if they ask you what's the common ratio, a lot of people say 2%. No. The common ratio is all that. The rate is just that. The common ratio is 1 minus 0.02. Now, some kids are going to say 0.98. Do you get 0.98 is the same thing as 1 minus 0.02? Okay. All right. So now, I think when you came in, if I had just said that, you'd had no idea what I was talking about. But now you know, oh, I can start with 12 million, and it's going to shrink by 2% each time. You could use a calculator if you wanted to just kind of do it by hand and go, well, I'm going to take 12 million, and I'm going to times by, you can do the 1 minus 0.02 in your head and go 0.98. So I'd take 12 million times 0.98, and I get my next number. And I know that's how many people are on the next year. And I could keep doing that for the next year and the next year and the next year. And there's a way to use the calculator, special fancy way to use the calculator on this, which I will teach you not tomorrow, but the next day. All right, cool. You now know everything. So let's start your homework together. There's usually some problems that we can skip. So find the homework. I know there was a lot of slides we didn't do, but I needed to do 2 days at once, so I skipped a lot of the slides. So let's just go right to the homework part. I'm still grading finals from last semester because it's a long story. So last night I'm not positive that I think I assigned a worksheet for this class, but I can't remember. It might be a Schoology quiz. Can you tell me what it is? It is a Schoology quiz. Okay, so let's do the first problem of the Schoology quiz together. The way I do Schoology quizzes is I make sure that they are small enough. If they're grossly big, I'll just chop a couple problems off at the end. Okay, and if they're small enough to be reasonable, then I assign them and I give you 2 tries. And after the first try, you get to see the answers. Because I know it's really frustrating if you're like, I got it wrong, but I don't even know if it's because I typed it wrong or just because I'm not doing it right at all. So it will give you the answers after your first try. But because of that, I can't just give you your second score. Because your second score will be perfect. Because you'll have seen all the answers, right? So I give you an average of the 2 scores. So if you really care enough to do it twice, you'll have seen all the answers in the first try. You'll get to average it in with your, maybe you got an 8 out of 10 the first time you do it again, you get a 10 out of 10, you'll average a 9 out of 10. So you always get 2 tries and the average of the 2 tries. And you get to see the answers after the first try. All right, question number 1. Seiji, please read it. Cool, I know that means we start with 20, we add 6 each time. What do they want?
The first question is it arithmetic or geometric?
What do you think?
Arithmetic.
Yep. It's arithmetic is the official way to say it. Arithmetic. So that's an arithmetic sequence, and what else do they want to know?
The first 4 terms.
What is the first term?
20.
20. What's the next one?
26.
Keep going.
32.
You're on a roll.
38.
Perfect. And you just do that exactly. 20 comma 20. Never put in spaces. Okay, and now what else they want to know?
That's it.
Oh, cool. If they had asked you for the common ratio, it doesn't have one because this one's arithmetic. But it could have asked you on tomorrow's assignment what the common, let me think, it's ratio. What?
Difference?
Yes, very good. There's something called the common difference. That's the common difference, is the 6. Because it's different by 6 each time, right? So the common difference is 6. Or you could say, when it goes from this to this, you subtract this minus this, and you get 6. And a difference is a subtract problem. So it works either way. So the common ratio is where you divide these two, and it's whatever number the whole number is that you're multiplying by. And the common ratio is different than the common difference. Because the common difference is where you're just adding or subtracting something. All right, cool. I think you're going to be good from here. But I know there's always a weird question. The first person you should ask is that person I ask you to introduce yourself to. If you get like stuck on number 6, say, hey, Seiji, what do you think number 6 is? Ask them for help. Maybe if you know somebody in here, you can ask them for help. But always feel free to ask me, because here's my philosophy on questions. The kids who ask the least questions They think that they look smart, but they usually do the worst. And the kids that come up and ask me lots of questions, like I remember my number one. I've taught for 34 years. I can still remember her. She would ask me like 3 questions every hour. And she also got a perfect final. Every single problem right on the final. Okay, so my point is it's okay to ask questions. If you ask more questions than everybody else, you might be the one who aces the final. Okay, so asking lots of questions does not mean you're dumb. Asking lots of questions means you care and you're bold enough to not be afraid to ask. Okay, so don't be afraid to ask. Be one of the excellent students and ask questions. All right, that's all I got for you for today. And I'm going to stop the video there.